Okay class, so we proceed with the example 1. So example 1, the question is evaluate, okay, the surface integral, okay, where is the surface of the cone, okay, of the cone z square equal to, wait, first. Okay, z square equal to x square plus y square between the plane z equal to 1 and z equal to 2, where the rxy equal to xi plus yj plus x square plus y square k. Alright class, so I think I need to highlight here. So you can see that from this formula they have r, is it? So r is an equation actually, but this r is a radius. So hope that you can distinguish or differentiate between these two r, okay? These are two different r, two meaning. Okay, r here represent an equation and r here is represent a radius. Okay, we're back to the question now. So what we need to do first, okay, you can see that this is the equation, okay. Alright, so yeah, based on this formula, so just refer to the formula here. So what we need to find out, okay, you already have the f, is it? Okay, you see the okay, f, yeah, we have f here. And then what we need to do now is we need to find out your RU, RV. Okay, RU and RV first. So this is the equation for R. So means that what's mean by RU here is you just differentiate R with respect to U. But from this question, they have no U and they have no V. So it will be RX and R, what else? RY. Okay. So it's just yeah, RU and RV is just a general equation. So U and V that U and V is depends on your question, okay? So your question now is exist of variable x and y. So Rx and Ry, okay? So you need to differentiate with respect to x first. So we have I here and then doesn't have any. So this one, if you what we call struggle to solve it, why not? You just make it become power, okay? Maybe if power you can see more clearly lah. So it will be this one, 3/2, is it? Sorry, negative half over 2. Differentiate here to x, and this is your k. So simplify. Okay, so you have I plus x. Okay, I simplify, okay, because this is 2 and 2 can cancel. So x square plus y square power negative half, and this is a k, okay. So how about ry? So ry we have g here is 10, it will be the same, x square plus y square negative half, but now it's a 2y. Okay, so if we simplify, so you will have here x square plus y square negative half k. Okay, so now find out cross between Rx and Ry. So Ijk, alright class, Ijk. So the first row is I is 1, J is 0, and this one will be x over x squared plus y squared. So this is how, okay, I just transpose it, I just transform it from the power become the fraction, okay, alright. This is similar, the meaning is still the same. I didn't change anything, I just change how we write it, okay, how we write it. Okay, now I is 0, j is 1, so same thing, this one will be y x squared plus y squared. Okay, so solve it. To get the I, you need to close a column I. Okay, and then this one will be 0 minus x over x squared plus y squared, and this is I. Oh my god, class, sorry. Alright, so then minus, okay, minus, okay, close the column J now. So we have y x squared plus y squared, and then minus 0. So minus 0, j. Okay, then plus, close the column k now, so it will be 1 minus 0, k. So simplify, so we have negative x squared plus y squared I minus y, x squared plus y squared j, and plus k. Right, so you will have this equation. Okay, done. We are done for that one, but what we need to calculate next is this is the magnitude. So you need to find the magnitude of it. So magnitude rx times ry, so it will become like this. Okay, magnitude. Okay, so magnitude means you need to power 2 for each of the element of x, y, z. So this is the for element I, j, k. So this is negative x square root this one, negative y. So you need to bring all together with the sign, positive, negative, right? And this is 1. Okay, you just bring the coefficient without the ijk. Okay, you just bring the what you call the function, okay, not the vector. Okay, right. So now this one will be x squared, this one will be x squared plus y squared, this one will be y squared, x squared plus y squared, and this will become 1. Okay, this one is equal, I mean the denominator is already equal, x squared plus y squared, so why not we just plus it. Okay, so it becomes x squared plus y squared, x squared plus y squared plus 1. Okay, then what else? Since this is equal, so we can factorize it, we can cancel it, so it become square root 2. Okay, so this is a square root 2. Right, so now we almost complete, so just substitute all that we have together into this function. So what is your function here? The function is from this equation. Okay, so this is your function. So z square, this is the original equation, z square ds. So what is your function here? Okay, your function here, this one actually. Okay, go to x square plus y square. Okay, and then what else? So now you substitute what you have here. So its magnitude of this is Z2 and then dA. Okay, so okay, Z2 you can take out from the integral, so you leave it here, this one. Right, so now you have x squared plus y squared inside here, so means that the variable involved is x and y. So of course dA here can be represent dx dy or dy dx. Okay, it's up to you. But now if you read it back, the equation give you the information here is z. Okay, this is your limit actually. Z1 and Z2 is your limit. So it's in terms of z, it's not in terms of x and y. So what we need to do is, okay, this is what you can do from when you read the question and you digest the information that you get. So basically what we need to do now is we need to transform, or we need to change from the Cartesian xy become the what you call cylindrical or spherical. So for here, okay, you can see that this is x squared plus y squared. So if you using this parametric equation, x and y and so on, okay, I already mentioned that x squared plus y squared is equal to r squared here. So why not we just substitute here is r squared. Okay, x squared plus y squared, now it's become r squared, and dA here, okay, is no longer dx and dy, it will be dr d theta. Okay, r d theta. Okay, r d theta. Okay, so if you are asking why they have r here, okay, I hope that you can refer back to the previous video in the topic in chapter 2, which is double integral. Okay, because this is not the time this is not the time for me to explain why r d theta and so on. Okay, because this is not that topic. Okay, this is another topic, another chapter. Okay. Right, so back to the question now. So x squared plus y squared is become r squared. So obviously this one must be changed also lah. Okay, the limit will be in term of r and dr lah, of course. Okay, we will read again this question. This question said that the plane z1, z2. Okay, alright. So since we have r dr theta, okay, So actually, okay, if because of Z1 and Z2, actually this is also it's mentioned what we call the distance. Okay, it's mentioned a distance for the cone to the plane. Okay, so maksudnya jarak antara or distance from the plane to the the plane. Okay, we have a cone, for example, so means that it's a represent the distance. So when I say it's a distance, so it will be a radius as well lah. Okay, distance and distance r and phi, and also something that relates to the distance will be equal. Okay, so now the radius will be from 1 until 2. Okay, it's a distance. Okay, distance from the origin. Okay, distance from the origin. Okay, it will be 1 and 2. Alright, now what's limit for d theta? Okay, this is a cone. Okay, how the shape of the cone? Okay, so this is the shape of the cone. And what's the base of this one? What's the shape of this one? It will be circle, is it? Circle. So circle means the limit, the angle inside that circle, the complete circle is equal to 360. Therefore, it will be 0 until 2 pi. Okay, 0 until 2 pi. So you can solve it now. Okay, you solve it. Okay, this one will be r cube lah. Okay, r cube. Okay, square root 2 pi 0 to r cube dr theta. Okay, so you solve it. So substitute all the value that you have here after that, and then suppose your answer must be this one. Okay, alright class. Okay, so this is one of example. So in the next video I will show you another one of example. Okay, regarding this topic lah, regarding surface integral. Alright.